You can leave.
All right. So if we wanted to solve an equation like 2 cosine theta equals square root of 3, and this is, we want solutions where theta, there are infinitely many solutions, but we want just solutions where theta is between 0 and 2 pi. So we say cosine theta equals square root of 3 over 2, just divide both sides by 2. And since square root of 3 over 2 is the cosine of a special angle, for this one I'm not going to use the calculator. I need to know my special angles. I know that this is true when theta is pi over 6, but I also know it's true in 2 places on the unit circle. The other quadrant where cosine is positive is the 4th quadrant, and the 4th quadrant pi over 6 angle is 11 pi over 6. So this is for the ones where the output is the sine or cosine or tangent of a special angle. It's just a matter of remembering what the special angle trig values are. So, like, oh, this one doesn't even give me the option to show the answer. But if we said, so it was pi over 6 and 11 pi over 6. There we go. So.
I don't know if it was those specifically that were tripping me up. I think it was other ones where I thought I was putting the right part of the angle in there, and it was.
Well, let's do it like this, where we've got multiple trig functions. So we got 32 sine t cosine t equals 12 cosine t. 32 cosine t times sine of t equals 12 times cosine of t. That's right. Okay, so for this one, I'm going to set this equal to 0. I'm going to subtract 12 cosine t from both sides. So I'll just have, be almost the same equation, just 32 cosine t sine t minus 12 cosine t equals 0. What I'm going to do now is I'm going to factor this. So I can factor, looks like I can factor 4 cosine t out. I got cosine t in both terms. Both numbers have 4. Oops, I forgot to take the cosine t out with 4. 4 cosine t times, I'll have 8 sine t minus 3 equals 0. So to solve this, 4 doesn't matter. I could divide both sides by 4 and that would go away. So either cosine t equals 0 or 8 sine t minus 3 equals 0. Cosine t is 0 when t is pi over 2 and when t is 3 pi over 2. X is 0 on the y-axis, and the values on the y-axis are pi over 2 and 3 pi over 2. Now for the other one, I need to solve that for sine t. I've got 8 sine t equals 3. Add 3 to both sides. Then we're going to divide by 8. So 3/8. Now 3/8 is an output of sine. So if you ever get a sine or cosine where it's equal to a number greater than 1 or less than -1, that's not going to be a solution. Because remember that sine and cosine, the range is -1 to +1. So, but 3/8 is between -1 and +1. So this is going to give us 2 solutions between 0 and 2 pi, but I'm going to have to use the inverse inverse sine. So one solution will be t equals sine inverse of 3/8. Okay. All right, so let's see here. If I do 3 divided by 8 equals, and then do sine inverse. Oops, I'm in degree mode, of course. All right, let's so 3, try again, 3 divided by 8, and then sine inverse. So the 0 point, let's do 3.844 about. So it's approximately 0.3844. Since this is a positive, this is also my reference angle. So my other angle will be in the second quadrant. That's where sine is positive. So another solution for t would be t equals pi minus that reference angle of 0.3844. So if we take our calculator, so we're going to do pi minus 0.3844, 2.7572. Okay, so now we can enter those answers in. All right, so it says we both want to give decimal and exact answers. So one exact answer was pi over 2. Another was 3 pi over 2. And then my approximate answers were 0.3844. And another approximate answer was, get my calculator, 2.7572. 2.7572. How many? It said 3 decimal places, so it said at least 3. That's supposed to say at least 3. I should fix that wording. Submit, and that's correct. All right. Hold on one second. All right, so we got 8 cosine squared minus 10 sine x minus 11 equals 0. All right. 8 cosine squared x minus 10 sine x minus 11 equals 0. Let's just double check that. Yep, okay. Now, this is hard to solve because I got both cosine squared and sine in the same equation. But if you remember, your Pythagorean identity, cosine squared x plus sine squared x equals 1. So I can replace cosine squared x. If I can solve that for cosine squared x, it's 1 minus sine squared x. So where the cosine squared x is, I'm going to change that to 1 minus sine squared x. So I'm going to do 8, parentheses 1 minus sine squared x, minus 10 sine x, minus 11 equals 0. All right, let's distribute the 8. 8 minus 8 sine squared x, and then the rest is the same. And then let's do the 8 minus the 11. So the minus 8 sine squared x stays the same, minus 10 sine x stays the same, 8 minus 11 is negative 3. All right. I want to see if I can factor this, but to factor it, to make my life easier, I'm going to multiply both sides by negative 1 to get rid of the negative. The right side is going to have no effect because it's just 0. So I got 8 sine squared x plus 10 sine x plus 3 equals 0. All right, so let's see here. I like to solve these with the method where I say I do 8 times 3 is 24. And I'm looking for a sum that adds to 24, that adds to the middle term 10, and multiplies to 24. So that's, 6 and 4. So 6 times 4 is 24. All right, so let's see here. Now I'll tell you a little trick, and when I factor this way, I know that my first two have to either be 8 and 1 or 4 and 2, but 8 doesn't go into either 6 or 4. So I'm going to have a 4 sine x and then a 2 sine x at the front of my two parentheses. And then let's see, in order to get that 10 in the middle, I'm going to have the plus 3 on the left, and I'm going to have the plus 1 on the right. So let me double check. I've got 6 sine x and 4 sine x. That's 10 sine x. And 4 sine x times 2 sine x is the first 8 sine squared x, and 3 times 1. I'm good. All right, so let's set up my two equations. 4 sine x plus 3 equals 0. 2 sine x plus 1 equals 0. Subtract 3, divide by 4. I'm going to do this in one step. So sine x would be negative 3/4, or sine x would be negative 1/2. Now I'm going to take now the one on the right is a special angle, sine 1/2. But let's see, negative 1/2, that puts it in the third and fourth quadrants, but I know my reference angle is pi over 6. So I need my third and fourth quadrant pi over 6 angles. So that's 7 pi over 6 is in the third quadrant and 11 pi over 6 is in the fourth. So that's for the right-hand side. For the left hand, I need to do sine inverse of negative 3/4. So let's do that. Actually, you know what? I think I'm going to do it with a TI, especially now we're doing negatives. Wait for my calculator to come up in a second. Now, the thing is, when I do sine inverse, I already know this. When I do sine inverse, of negative 3/4, I'm going to get a negative angle. Because sine inverse spits out either a first quadrant angle or a fourth quadrant angle, but if it spits out a fourth quadrant angle, it's a negative angle, okay? So the absolute value of this is the reference angle. I can add 2 pi. That's going to be one of my values, 2 pi. That gives me my fourth quadrant positive angle. So 5.435. So this is equal to roughly, what was it? Negative 0.8481. But I added 2 pi to that. And I got 5.4351. And then I need the second quadrant angle. I mean the third quadrant angle. I'll do pi plus 0.8481. Will be approximately. So pi plus 0.8481. About 3.98. It'll be 3.990 to 3 decimal places. 3.990. All right, so let's put those in. Now this one actually, okay, so this one, let's see. I think this one says decimals. I'm going to try, I need actually to fix this one so that when it comes out to a special angle, it's okay. Let's see, so I got 3.990 and then 5.435. I'm going to see what happens if I put pi, oops, sorry, it was 7 pi over 6, 11 pi over 6. Oh, it gave credit for that. Perfect. I put the parentheses not where I wanted them, but the answer, it was equivalent. There we go. So it took the exact answer for the 7 pi over 6 and 11 pi over 6. But it should take, let's just double check that it takes the decimal answer too. So let's do 7 pi over 6, 3.665. So let's replace 7 pi over 6 with 3.665. Yep, it takes the decimal or the exact answer for pi. So that's good. All right. So that's one where you have to use the Pythagorean identity. Then you have to factor and set each factor equal to 0. One gives you exact answers, and the other you need decimals. All right. What's next? Richard, did you have any questions? From 8-1?
That looked good. that made a lot more sense. When you did all that. How about later in 8.1? Like
Let me see.
12, 13.
Okay, let me see if Scott has some questions.
That's fine.
Just from
Yeah.
8.1.
What's that?
Just questions from 8.1.
Just from 8.1? Okay. Hopefully watching those in 8.2 gives you some ideas too. Let's see here. All right. What did you have in 8.1, Scott?
Solving for tangent in number 8.
Okay, let's make sure. Okay, well, so there is a formula for tangent of 2x, but the easiest thing is if you've got sine of 2x and cosine of 2x, tangent is still sine over cosine. So, I mean, well, let's still do this one. So it says if sine x is 1/3, find sine 2x, cosine 2x, and tangent 2x. Ooh. Okay, so we got sine x equals 1/3. Oh, it did. I think it told us what quadrant we were in too. First quadrant. Okay, so that means both sine and cosine are positive. It had to be first or second because the sign was positive, but it told us it was first. Okay, so we want to find sine 2x, cosine of 2x, and tangent of 2x. Now, there's 3 versions of the cosine formula because of the Pythagorean identity. And so we have one version is cosine squared x minus sine squared x. One is if I change sine squared to 1 minus cosine squared, I get 2 cosine squared x minus 1. Or if I change cosine squared to 1 minus sine squared, I get 1 minus 2 sine squared of x. And actually, since I have sine, I can already do that. I got 1 minus 2 times the square of 1/3. The square of 1/3 is 1/9, so that's 1 minus 2/9, which is 7/9. Okay, so cosine is 7/9. All right, let's go back. And now sine is, unfortunately, there's not a version of sine that I can do where I only need that sign. So what I have to do now is use my Pythagorean. You can either use your Pythagorean identity or a reference triangle to find cosine of x. I'm going to do cosine squared x equals 1 minus sine squared x equals 1 minus 1/9 equals 8/9. But that's cosine squared, so cosine of x is equal to the square root of 8/9, which is the square root of 8 over 3. I don't care if the square root of 8 can be simplified to 2 squared root of 2, but the question won't require that. So then 2 sine x cosine x is going to be 2, and then sine of x is 1/3, and cosine of x is square root of 8 over 3. So that would be 2 times 1 times square root of 8, 2 square root of 8 over 9. So, or, like I said, square root of 8 is 2 square root of 2, so you could write that as 4 square root of 2 over 9. But let's assume you did not realize that you could simplify the radical. Okay, 2 square root of 8 over 9. All right, and then now tangent is sine over cosine. The only time really the tangent formula is useful is if you only needed to find the tangent and you didn't need to find the tangent of 2x and weren't asked to find sine of 2x and cosine of 2x first. So let's see here. Although you still could do it by finding those, you just wouldn't have to. All right, let's see here. So sine of 2x was 2 square root of 8 over 9. And cosine of 2x was 7/9. Well, if you got 9ths divided by 9ths, the 9ths cancel, so this will just be 2 square root of 8 over 7. 2 square root of 8 over 7. And submit. And there you go. And I'm pretty sure that it's going to give it, yeah, it's going to give the more simplified answer. But that's fine. You see, it takes it even without that. All right. Is that helpful?
That is, thank you.
Okay. All right. Were there other ones from 8.1?
I think, well, like 13.
13? Let's take a look at 13. So this is half angle, okay? All right, so let me show you. So this is a little trick that I do. As long as we're on this, and I don't know how many people watch these videos after the fact, but so there's sum formulas, there's difference formulas, and there's double angle formulas, and there's half angle formulas. All right, that's a lot of formulas, right? And these are going to be on the next test. But if you can remember the sum formulas, all the rest comes straight from those. Actually, let's start with the cosine sum formula. That's usually, when people are teaching it, usually that's the first one they teach. Cosine of x plus y. That's equal to cosine x, cosine y, cosine cosine is usually how I remember it, minus sine sine x, sine y. Okay. All right. Now, so let's next do the difference formula, cosine of x minus y. So let's see, that just means every minus y is the same thing as plus a negative y. So everywhere there's a y, I'm going to change it to negative y, but cosine of negative y is the same thing as cosine of y. So this, the first term is just going to stay cosine x, cosine y. But then sine of negative y is negative sine y. So that's going to change the sign of the second term. So it'd be cosine x, cosine cosine plus sine sine. Now why is it that, let's right over here, cosine of negative y, oops, that doesn't look like a negative y, cosine of negative y equals cosine of y. Why is that? Because if you think about cosine, it's symmetric with respect to the y-axis. That's not a very good drawing of cosine, but it's the same value no matter what you plug, whether you plug in a positive or negative value, you get the same answer. Whereas sine is what we call an odd function. It's symmetric with respect to the origin. So if you have the same values, positive and negative, the outputs are opposite. So sine of negative y, if you have a negative inside, it flips the sign of the whole thing. So that's how I got that cosine of x minus y. Now the double angle formula, 2x is x plus x. So that would be cosine x, which is cosine squared x, minus sine x minus sine squared x. So that's the double angle formula, is just by doing it as x plus x. Now I'm going to assume you can do this similar for the sine formula. You just need to know the sine formulas. But this is how we can do the half angle formula. Basically by realizing that x is half of 2x. So the other thing we do though is we want to use the versions of the cosine and sine of the double angle formula that have just one trig function. So let's take first of all cosine of 2x. That's let's do it in terms of cosine squared. That's 2 cosine squared x minus 1. We can use a Pythagorean identity to show that that's the same formula as the one above. Okay, let's solve that for cosine squared. So I'm going to have, first I'm going to add 1 to both sides. So I'll have cosine of 2x. Actually, let's do it right underneath. Cosine of 2x plus 1 equals 2 cosine squared x. And then I'm going to divide both sides by 2. For this, I'm not going to bother with writing a whole nother line. And then I take the square root. So cosine squared x, cosine x then equals the square root of cosine of 2x. Oops, that plus 1 isn't supposed to be in parentheses. Cosine of 2x plus 1 all over 2, all under the radical. But remember, when you're taking the square root, I could have squared a positive or a negative, so I'm going to put a plus or minus. And over here, we say the sign depends on quadrant. Okay. All right. And then, well, x is half of 2x. So I can rewrite x as x over 2. And then that's plus or minus the square root of cosine of x plus 1 all over 2. All right, so that's the half angle formula. So let's go back and look at this problem. So we're in quadrant 1. If you take half of, so in quadrant 1, your angle is somewhere between 0 and 90 degrees. Let's use degrees for a second. That's easier to think about. Well, half of 0 is 0, obviously. Half of 90 is 45. So the half angle is between 0 and 45. So it's still going to be positive. So I'm going to use the positive square root. So cosine is 1 over 7. So let's see. Well, here we go. Cosine of x over 2 then is the positive square root of cosine x. And cosine x is 1/7 plus 1 over 2. A seventh plus 1 is 8/7 over 2. And if you divide a fraction in half, it doubles the denominator. So half of a seventh is a 14th. So this is the square root of 8/14, and that reduces to the square root of 4/7. I don't care if you have a radical in the denominator, so I can put that in as the answer. Oh, shoot, I forgot to click love it. All right, that's the problem. So let's see here. So that was this one. So that was the square root of 4/7, I think, right? 4/7, okay. All right. And it's similar for the other one, for sine. So let's see here. So sine, I'm going to use the double angle formula for something that only has sine. Sine of 2x equals 1 minus 2 sine squared x. No, 2 cos. No, that's cosine of 2x equals 1 minus 2 sine squared x. So let's solve that. I'm going to add the 2 sine squared x and subtract the cosine. So sort of swap their sides. 1 minus cosine of 2x, divide by 2, and take the square root. So that cancels those two. All right, so now I'm just going to replace x with x over 2. I'm going to use the positive square root again. So 1 minus a seventh over 2. 8 7/7 minus a seventh is 6/7 over 2, which is the square root of 6/14, which is the square root of 3/7 when I reduce. All right, so this one, square root of 3/7, and then tangent again is sine over cosine. So I got the square root of tangent of x over 2 is the sine of x over 2, square root of 3/7, over the cosine, square root of 4/7. When you got a square root over a square root, you can put both of them under one big radical. And again, the sevenths cancel, so this becomes the square root of 3/4. This I will, because the bottom is a perfect square, I'll rewrite that as the square root of 3 over 2. Now you might say, ooh, that's a special angle, but it's only a special angle as the output of sine or cosine, not of tangent. All right, so we got square root of 3 over 2. All right, and that should give us correct answers. There we go. And again, the shown answers are going to have the denominator rationalized. Square root of 21 over 7, 2 square root of 7 over 7. Well, square root of 3 over 2 was rationalized. So, all right. So again, here were our formulas. Here's the cosine half angle formula. And the cosine half angle is 1 plus cosine, and the sine half angle formula is 1 minus cosine over 2 square root of that. So lots of formulas, but they're all related. All right. Richard, did you have another question? You had a couple questions from 8.1 also, didn't you?
I don't think I had anything else for 8.1, honestly.
Okay, good. Let's go with that. And Scott, did you have any more from 8.1 that you wanted to look at?
I had number 9.
Number 9. Okay. So this is just a matter of recognizing that cosine squared minus sine squared is the double angle formula. So then A is twice 40. So cosine of 2 times 40 is cosine squared 40 minus sine squared 40. So this is just, A is just twice 40. And B, cosine squared minus sine squared, is again the double angle formula for cosine. So 2x is twice, or sorry, B is 2 times 2x, or 4x. That's it. There's not any work to do. It's just recognizing those as the formula.
Okay, I see.
Yeah, and let's see. Is there another one? Is there another one?
12.
Okay. Is this? Yeah. So again, double angle formula. So this is the same question. I'm surprised there wasn't one that used the double angle formula for sine, but it doesn't look like there is. I wonder if I read. So this is 38 cosine squared minus sine squared double angle formula. So I do 38 times 2, which is 76. Oops. And then I do 8x times 2, which would be 16x. What I'm wondering is, let me see if I can. I was wondering if I could get it to, if there was, I didn't know whether or not there was a version with the sine double angle formula. It doesn't look like there is. So it's just, again, recognizing that that's the double angle formula. Yeah, all right. Yeah, for some reason I thought there would be one where it used the sine double angle formula, but there does not appear as. Oh, yeah, this one does. So 2 sine cosine is the double angle formula for sine. So sine A must be sine of 80. Sine of 2 times 40 is 2 times sine of 40 cosine of 40. And this one would, with 2 sine 4x cosine 4x, that would be sine of 8x, double angle formula. So yes, if you redo it, you might get a double angle formula for sine. All right.
Okay, that was it for me. Thank you.
Okay, Richard, did you have another question for me too?
Yes.
Okay.
Well, number 6, I've got half the answer.
Number 6. Okay.
Yeah, on one I did, and I can't figure out how to get the other part of the answer.
Okay, number 6. Actually, let's see here. Oh, that's a just question group. Okay, hold on. Oh, you know what? Well, I don't know. Let's see here. Let's just. I'm going to pull it up. Does your 6 look anything like this?
It's similar. Mine's a sine. Mine's a sine x, not a cosine.
Is it equal to a negative?
No, it's a positive also.
Okay, so you're going to get a first quadrant angle. When you take the inverse sine, you get a first quadrant angle. Then when you that's your first quadrant angle. Then to get your sine is also positive in the second quadrant. So you subtract that answer you got for the first quadrant from pi to get your second quadrant angle, because that first quadrant angle is your reference angle. Does that make sense?
Okay, so.
And actually, this one is even trickier. Let's do this one. Cosine x equals negative 0.45. I'm going to try to do it quickly because I forgot. So I realized I need to click I clicked the wrong thing, and that's why my thing ended. And it's about to end again. If it does end, just click the part 2 link.
Okay.
Right, but let's see if we can do cosine of x equals negative 0.45. So the first thing to do is go to the calculator. And I'm going to do second cosine of negative 0.45. Now, I happen to remember that cosine inverse in the second of a negative is in the second quadrant. There's a few ways I can find my third quadrant angle. Let's draw a quick picture of my second, of where an angle in the second quadrant would be. That's a terrible thing, but so in this case, this was 2.038. So I need to find this angle here, the third quadrant angle. So one way I could do it is find theta prime here and then add that to pi. But even easier is recognizing that the angle on the bottom from 2 pi backwards would be, I could just use that 2.038 directly. So what I could do then is do 2 pi minus that answer. And that's my second answer. So it's just a matter of recognizing where those are in the circle. All right?
Okay, so yeah,
Okay.
so
All right. Keep practicing. Send me a question if you got it.
I will.
This is about to cut out. I am going to open up the other half. You're welcome to come back on if you have some more questions.
Okay.
All right?
All right.